Hello there, welcome to A2 Maths on Specimen Paper 2, and here we're looking at question 12, an implicit differentiation question. So a curve C is given by the equation sin x plus cos y equals 0.5, x is in between pi by 2 to 3 pi by 2, and y is in between minus pi to pi. A point P lies on C. A tangent to C at point P is parallel to the x-axis. Now, as soon as I'm reading here parallel to the x-axis, I'm thinking that the tangent is a flat line, or in other words, the gradient, or in other words, dy by dx, is equal to 0. Find the exact coordinates of the points P, justify your answer. So, I'm thinking dy by dx equals 0, so we're going to have to differentiate this expression here with respect to x. So sin x differentiates to cos x, cos y differentiates to minus sin y, but it's with respect to a different letter, so we need to do dy by dx at the multiplier afterwards, equals 0.5 differentiates to 0, so we put a 0 at the end there. Now I know that at coordinate P, dy by dx is equal to 0 because the tangent is a flat line, the gradient is 0, so therefore the rate of change of the y coordinates is equal to 0. So I'm going to replace dy by dx with 0. Sin y will now multiply with a 0, so I'm just left with now cos x minus 0 effectively equals 0. So now my equation is super straightforward. All I now need to do is inverse cos of 0. I get solutions here of pi by 2 and 3 pi by 2. Just check the domain. Oh, just pi by 2, not 3 pi by 2, because that's not in the domain. So just pi by 2 here. So now all that's left for me to now do is work out what my y value needs to be. So substituting into the original equation, sin pi by 2 plus cos y equals 0.5. Sine of pi by 2 is 1, so it's going to be 1 plus cos y equals 0.5. Take away the 1 onto the other side, you get cos y equals minus 0.5. So let's now grab our calculators. Y is going to be equal to cos inverse 0.5. And the inverse cos minus 0.5, minus 0.5 is going to be 2 pi by 3. Now be careful what your second solution here is going to be. Cos is in between, the y value is in between minus pi to pi, so it's going to be from here and then back to here, so that alternatively the other y value is going to be minus 2 pi by 3. So therefore, the coordinates for P are going to be, the x value was pi by 2, and the y value, the first one was 2 pi by 3, and the second value of P, the second coordinate of P could be at pi by 2, and the second y coordinate would be minus 2 pi by 3. Lovely, so there we are. That's the answer to question 12 there. 7 marks for that there. A little bit of implicit differentiation. Identifying that our tangent is going to be flat, therefore dy by dx equals 0. Super important step there. And then just working out what cos of x is equal to and cos of y is equal to. Lovely, 7 marks for that. Let's now move on to question 13.